welcome to Intro for Computer Science. The Trans Academy, this is the second lesson. I'm Lucia, and yeah, let's get started. All right, so since this is the actual first lesson where we're actually going to be touching on code/concepts. What exactly is computer science about, or specifically what is function IO and variables have to do. It all has to do with data, has to do with how you store it, how you access it, how you change it, how you present it. So a very key concept in computer science is the concept of a variable. On the workshop last week, we did briefly touch upon it, but in the case of as an example for what a variable is, it is the value directly before the equals sign that you would typically see. So for example, in this case, A is the name of the variable, and 1 is the value. B is the name of the variable, 2 is the value. C is the name of the variable, and in this case, we're assigning it to the value of A, which means it's going to have a value of 1. So, I guess I'll just ask a question for the group here. Who here knows what the value of C would be? So, from last week's workshop, we used the print function to demonstrate or to output the result from our formulas. So, by this case, it should output the value of C. So, I guess an open question here. What is the value of C on this? Go for it. Yep, exactly. Yep.
Is it 3?
Okay, so I see what you mean. You're good. You want to try again?
It's 1 then.
Yep, you got it. I do see how you could have got 3, though, to be fair. All right. So, another thing we're also going to be covering on this is the concept of a type. So, in the case of these variables, each of these has a type. In this case, it's not explicitly listed, but the type of each of these, being a whole number, is an integer. So 1 is an integer, 2 is an integer. If we were to set this to say something like in quotes, like hello world, it would be a string in that case. All right. This goes a little bit more into detail on this. So that said, if anyone has any questions at any time during this, just raise your hand, yell at me, and I'll stop and answer them. So, all right. So to show an example here, right? All variables have a type. In Python, this is assumed dynamically, which does about what you would expect. It is going to assume the type based upon the value that you give it. So in the case of the first one, it is an int, because we are setting it to a whole number. In the case of the second one, it is a string, because we are setting it to a series of characters, in this case, hi. We did briefly show this a bit on the workshop. We didn't really get into it a whole lot, but on the quadratic formulas solution, the quadratic formula solution was not an integer, it was a float. Specifically, it was 2 floats. And in the case of Python, and programming in general, a non-whole number with a decimal is referred to as a float. Now, this last one's a little fun. So, you can also have what is referred to as a list, which is a variable that's going to contain a set of values. So, in this case, we have a list that contains the values of 1, 2, and 3. This does get very in the weeds, and in the end, you do end up having data structures. That's how you organize a lot of your application and your data. We're not going to get super in the weeds on this specific one during this lesson, so don't panic, but for the purposes of demonstrating how some of these work during this lesson, felt it was important to mention. All right. So this is fun. So if you are curious, and I'd recommend not doing this right now while you're in VR. But if you are curious at some time afterwards, feel free to open up Replit. There is a function you can call, refer to as type, and it will return to you the type of the variable that you're using. So one will return type int, the second one will return type string, the third one will return type float, and the fourth one will return type list. All right. So before we go on to the next one, are there any questions on this area so far? Go for it.
What are variables useful? Like, as in coding, what are they useful?
So that's a great question. So a use of a variable, right, is that way you can store the value within your program, right? So let's say, for example, I am logging into a website, right? I need to store the username so that way I can send it back to the server so it'll log in, right? In the case of that, I would use a variable in order to store that value while I am currently handling it and before I, be complete with it or be done with it and send it off. Or let's say you have a calculator, right? In the case of a calculator, you would have a variable that's going to be the input that is given to you from the user, whatever value they've decided, whatever button they've decided to click. And you would have a separate variable for the actual final result. The reason that you would use this is, well, yes, you can, just chain everything together and start putting all of your individual functions inside of each other. It would become very difficult to read and to make sense of. It's a good question, though. I guess the short is it's used to store the data in your program. All right. I thought I saw a question over here. My apologies. All right. All right. So we did this a little bit during the workshop, but sometimes you want to, for example, print a type or you want to print a variable, and it's not going to let you print it, right? So the reason it wouldn't let you print it is because you're trying to print a type that the print function or print call is not going to accept. So print is going to accept a string, right? Which means that if you cast in or if you pass in, my apologies for misspeaking on this, if you were to pass in a integer, it may not exactly do what you want. So that's part of why, for example, we used the little str function. Let me stand up here real quick. So str function, for example, being an example of a way to cast the data that you currently are using to a string. A lot of casting that you will see in Python is done automatically. So for example, if I were to divide a by b here, or 1 by 2, it would automatically convert to a float. But sometimes you do have to do an explicit typecast or an explicit cast. and I guess to clarify for terminology here, typecasting in computer science is typically just referred to as when I want to change between two different types of variables. As to why this is useful, oftentimes you need to deal with data that's not exactly in the format you expect. So like, for example, let's say you get some input from a user. The input is given to you as a string. You know it's a number, and you need to do some math on it. You convert it over to a number, and then you would do your addition. All right. Any questions on this part? All right. All right. So, important concept of computer science is the concept of input and output, right? So, input, for example, being the input of what the user has provided to you, and the output being, or input can also refer to a file, and the output being the value that is returned to the user, what's printed on screen, what they see at the end. So here's a fun one. So Python has a function called input. What input will do is, if you were to punch this code into a computer right now, what it will do is it will ask you for your name. And then once you hit the enter key, it will capture that input, and it will assign it to the variable on the left-hand side, in this case, x. So the end result here would be, if Apple had typed this in, it would be hello Apple. If I typed it in, it'd be hello Lucia. Or random, but you know. All right. My apologies, I just hit the back to the first slide button. Okay, there we go. Just a fairly high-level overview, but are there any questions on this area? All right. So we're covering input so in this case, the input function is gathering your input. The print function is returning your output. All right. All right, so here's the fun part. And a pretty fundamental concept in computer science. So also one of the reasons we're teaching it now, because otherwise we won't be able to build on it. So print is a function. So what is a function? A function is a set of instructions or commands that can be reused. So there's plenty of built-in functions, but we can also define our own, and we frequently will be defining our own. The str function that the str value used a few slides ago is a function. So b equals stra is a function. Print is a function. And what functions do is they're going to take an input referred to as a parameter, and they can return a value. They don't always have to, but they can return a value. And they're going to consist of an actual body that shows or contains the actual set of instructions. I feel that showing some code on this will probably clear this up a bit. All right. So we have a function here called an add function, right? Okay. So in this case, the name of our function is add. Our parameters are a and b. The type that we expect the function to take is int. So if we were to give it something that's not an int, we would get an error. It is also supposed to return int. So when we are calling this function, we know that it is going to return an int for us. The return keyword, what it does is it defines the specific value that will be returned from the function. Our function body is all the commands that are directly below this, that are still within the function itself. In this case, we're going to return the value of a plus b. To show an example of this, for example, being used, right? So let me go back here real quick. So input is a function, right? So input internally inside of Python is, it has a parameter for the string that's going to be presented to the user, and it has a return statement which is going to return whatever input it captures. Very similar to how we're doing this here. Let me check this real quick. All right. So next slide is some clarification on this, but this is also a fairly complex topic. So does anyone have any questions on this so far? Go for it.
What's the def in front of add?
That's a great question. So what that does, so in programming, right, there is, in languages in general, there is usually a keyword that defines what the function will be, right? Or notifies the system that this is going to be a function. So in the case of Python, this is def to define that it is a function. Some languages will actually just use function right there. Others will use func, they'll abbreviate. But languages have a keyword that is reserved that the language recognizes as defining the function. Return is also a keyword in this case. So the return word notifies the language that this is the value we wish to return. It's a very good question, though, and Python is not very clear-cut that that is a function. So some languages will actually tell you that it is a function, like they'll just, like the definition for a function is named function. Python is unfortunately not one of those. So definitely understand the confusion on that one. Good question. All right. All right, I'm gonna go to the next slide real quick. So, a little bit of extending on a function, right? So, for example, you don't always have to provide a type. It is, in general, recommended, so you can tell what is going on, but you don't have to. You also don't always have to return a value. In fact, a lot of the time, you probably won't want to return a value. These are referred to as, let me just see if we're actually covering this here. No, we're not covering this here. So, for the curious, a function with no return type is referred to as a void function. So, it is a function that will not return any value. Okay. For the curious, yes, this is why we use variables. Because this is very hard to read. All right. So, what do we got here? So, we have 3 plus 4 being called on our function. We are returning that. And then we are going to add the value of that to 2. And then we are going to add the value of that to 1. Now, would anyone like to hazard a guess at what that's going to return? So let's break it down. And oh, thought I heard someone. Go for it.
I'm guessing it's adding 1, 2, 3, and 4 together.
Yep, you're 100% correct.
So, but it's like the integers will return a and b. So you're adding 1, which is an int. You're adding 2 is an int. Adding 3 and 4 is an integer because you've said, but we don't have an a and b defined, do we?
So this is a little tricky, the way it's written. Another way this could be written, I just realized I had a marker on this avatar, so that might help, right? So here's how this works. So the way add is seeing it internally is, do not tell me this marker is going to decide to break today.
It's working. I can see it.
Go for it.
No,
Oh, I can see. Oh, I got you. So you guys can see the marker, but I can't. Okay, that's perfect. All right. So, let me try on this one then. So the way we have this set up, or the way add is being called on this last one, right, is 3 is A, and 4 is B. Okay. So this is going to return. So this is going to return a value. And you are correct, we are adding these together. In this case, that value is going to be 7. This return value is then going to be used to be passed into here. So that returned value now becomes the B parameter for the next call. So it becomes 2 plus 7, which is 9. And then we would pass this in. And that ends up becoming 10. My marker does not like this world.
Okay, that makes perfect sense. So,
yeah,
the comma between 3 and 4, it's basically saying this isn't just one integer, it's both a and b. And since it's returning
correct.
a plus b, it's adding those two together, and then so it's adding the rest together, and so the print will be 10. Correct?
Yep, exactly. Yep, you hit the nail right on the head.
Okay.
And this is also one of the reasons that we use variable definitions, right? Because having this with variables, we would have each add on a separate line, and we could much more clearly see what's going on. So that was a tricky one. So are there any questions on that area?
Just for the last, oh, sorry.
Go for it.
Here's my hand. For the last one, I'm not too sure. Like with the int return a plus b,
Mm-hmm.
should not just be like a print? Because
So
I guess it's just
no, you're good.
confusing to look at the start. When you go through it, it makes sense.
It's very
confusing.
It's very confusing, and there's a reason that we typically don't write functions like this in a production or professional setting, because what you are seeing is very much correct, right? Because your instinctive reasoning is to read the code from left to right, right? So, which, makes sense. The problem is that you see parenthesis here. Okay, well, I need to know what this value is. Wait a second. Oh yeah, no, that's right. I need to know, okay. So I need to know what the final result. Let me back up for a second on that, because you're 100% correct. So, code is read from bottom to top, right, and left to right. The problem is when you define values in a way that you have to read all the way to the end of the line to figure out what the value is, it's not exactly the cleanest, right? So, in this case, you, to a certain extent, have to follow where the parentheses are here, right? So, this is the beginning of the value that print is expecting, and this is the end of the value print is expecting. You guys can see the marker, but its phases in and out for me.
Uh,
So,
I can see it.
yeah, I apologize if I'm drawing multiple times. So, in this case, we'd have the last parenthesis and the very first parenthesis, right, to define the value of what print should be, right? So, we can infer some logic, right, that whatever this add function is going to take for its second input is going to be the result of everything over to here, right? So it's going to be everything over to the second parent. And, rinse and repeat on that. So, for example, for the third add, we would do the same right here. So the third add, we finally have values that we know what the both of them are initially. So in this case, 3 and 4. As I said, do not write your code like this, because this is very hard to read.
Just to follow up, like if you were, oh, go ahead. Sorry.
Go for it.
Say if you were to write code like this, as you said,
Mhm.
you wouldn't do it in a professional capacity. But I
Mhm.
guess would you change the 3 and 4 to be the A and B of the 3 and 4 to be the first one, so there'd be no
So,
potential print issues?
so if I were to, and I can type this out and drop it into the chat afterwards on exactly how I would do this, but in a professional setting, what I would do is I would break each of these adds onto a separate line. So I would do like X, Y, and Z, right? And the value of X would be the add with 3 and 4. The next one would be the add with 2 and X. And for Z, it would be the add with 1 and Y. That's how I would break it down, because functionally that's what's going on. Is it's under the hood, it's assigning each of the outputs of this specific function call over to a separate variable, which is just being temporarily stored and used. We're just not explicitly defining it. If we explicitly define it, it's a little bit easier to read. At least that's how I do it.
Yeah, that's how I did it when I was being taught.
Yeah. If you're wondering why we wrote it this way, yeah, anytime. If you're wondering why we wrote it this way, it's a great way to explain how function returns work, right?
True.
I saw a hand. Anytime. I saw a hand over here.
Ash, can you go grab a pen from the cafe so she can see your marker?
Much appreciated. Thank you.
I would, but I
Gotta
got so.
I'm very glad I put a marker on this. I saw Spot type out a question earlier. Oh, thank you so much. Oh, cool. It's almost the same. It's pink. I love this. To be fair, I probably should have thought of it earlier, but, details. Explain what you mean by the bottom to top part. Not exactly what you mean. Okay, so is there a good slide where I can actually show this? Because this isn't exactly the best slide to demonstrate this. This one's pretty good. So, no, this one's not good, actually. Yeah, this one's a lot better. Okay. So, if I were to run this code, right? Getting very good use out of play space move today. All right, so if I were to run this code, the first call is going to be this part up here. It's going to be the time to cast some types, right? The next line executed is going to be a equals 1. Okay. Next line will be a plus a, which in this case is going to output 2. And then we ultimately end up executing b, which is a little bit fun here. It's going to end up outputting. This is a gotcha, and I love it when languages do stuff like this. But what it's going to do is it's going to output. Okay, what is the value of b right now? No, value of a is going to be a1. Okay, yeah. So it's going to print 1 as a string. Okay. That's what I mean by top to bottom. And left to right on code. All right. It's a good question, though, Spot. All right. Do I have any slides left, or was that the last slide? Ah, yes. Okay. That is the last slide I have. So I guess I'm just going to open this up to questions. If anyone has any questions on anything we've covered so far, or we want to go back through an area that we might have gone through too quickly, it's open. So by all means. Go for it.
So, can you go back to the last slide if you don't mind?
Yeah, absolutely.
Great,
So let me go previous. This one right here, right?
Yeah. My brain's still trying to process it, but I'm thinking the reason. Okay, so that green ad, I forgot what we called it in the thing, but that's the reason why it's able to add the sum of a and b in the print section, correct? Because we define it at the top.
Correct. Correct. Yeah. So the way this is named, right? So that so what that's going to do is that's actually going to be the name of your function. So in this case, it is add, right? So let's say for fun, right? Let's just say for fun, I instead named it subtract, right? In this case, if I just change the name, we're going to have a function named subtract that does addition. Probably not what we want, but my legs broke. Not exactly what we want, but it does, accomplish the goal in that. So in order to call the function, right, in its current state, that's what these add calls are for. And when I refer to call on this, I apologize. If I use a piece of terminology that's unfamiliar, by all means, correct me, stop me for clarification. To call a function means to, in this case, to do this, right? So it means to actually write the code in that executes that specific function. Hopefully that answers your question.
It does. It was more so like I was trying to think. Okay, how in the world is this connected? I was like, oh, but then I'm like, wait a second. I'm like looking at it.
Oh yeah, yep, exactly, yeah. So the name of that the green word in this case is the name of the function. So
Yeah. All right.
it's the name of what you're going to call. Yeah.
And you have to put def before you do add, or is that do it by default in other Python environments?
In Python you have to. Not all languages
Okay.
require it, but in Python you do.
Excellent.
Yeah. For the purposes of clarity, for anyone who wants to apply this to other concepts in the future, most mainstream languages will require you to do that. Yeah. All right. Good question. Hmm. All right. For the curious, so I guess let me, before I continue on with this, are there any questions or concerns or anyone like to clarify or add anything? Yes, Oblivion.
I'll bring something up because it, I feel like it would be a decent question. What would happen if one were to set the variables a and b before the function outside it?
You're referring to the scope on it, right? That's what we're talking about?
Basically, yeah. But like, let's say
Okay,
you
so
have two different scopes with the same variable names. What happens in Python?
that would, once that's a shadowed variable, if memory serves, the way it's done, right?
Mm-hmm.
So what she was asking is if I have defined A and B above this, let's say I have defined A as 7 and I have defined B as 2, and I have defined that before I even call this. So for example, on this first call, right? So this first call, the function's been called with 3 and 4. What happens here? That's a great question. So this is referred to as shadowing a variable. It will actually throw a warning in some environments if you do it, specifically because it results in code that's a little bit harder to read. But, wow, that is hard to read from there. Okay, fair enough. This is referred to shadowing a variable, right? So in the event that I've defined it on a higher scope, and I need to cover what scope is on this. So each function has a scope, right? So this is a scope, right? So if I define a variable inside of here, let's say I define c equals 100, c is only accessible inside this function. The moment I go outside this function, c no longer exists. At the top level of your program is going to be a different scope, typically referred to as global scope. If you define something in global scope, which is most of what we've been doing so far, in fact, pretty much all of what we've been doing has been global scope, up until these functions. So if I have something in global scope, then I can access it wherever. But if I define something in a smaller scope, it's going to instead take the value I have defined. So in this case, we'll still end up with the same output, but you're going to be looking at your code wondering, why did this not output what I expected? There are moments where that could be useful. Let's say you want to set a value and then access it inside of the function and you don't want to redefine it every time. It can be very useful. But doing what's referred to as variable shadowing, not usually recommended, but to answer your question, that's what would happen in this case. Because I know someone's going to correct me, yes, there are some languages where shadowing a variable is the correct way to override it. Not going to get into scope on that, on the more esoteric use cases. All right. Go for it.
Sorry, question again. Do you know after the int it says it's going to int?
Yes. So that is a... Go for it.
Is that needed for it? Or it's like, what's it for, I guess?
It's mostly what's referred to as IntelliSense, or a hint for the actual Python runtime. So I guess you have two things. So there's a few reasons to have this here, right? So because you don't actually need to have this, it's nice to have, and it's definitely recommended, but you don't have to. So the reason this value is here is it's to notify the environment that you're programming in that when you call the function, that you expect it to be an integer. It's also used to notify to you that if you do call this, like let's say you call this with a, let's say I call add with a string. If I do that, let me back up for a second here. This is what's referred to as a return type, right? So if I'm working on this function and I decide one day I want to actually make it return a string, Python will tell me, no, that's silly, don't do that. And that will be both on your interpreter, like on the interpreter, the actual thing that runs the Python code, and it will be on the text environment itself, so the area where you're actually editing the code. To answer your question, though, you don't have to have it. It's just very much a nice to have in this in Python.
That's good to know. Thank you.
Yeah, anytime. Do we have any questions from the Discord?
None haven't otherwise been answered by other helpful folks or Professor Apple's in the chat too and keeping an eye on some stuff.
Oh, that's excellent.
Where they can. Actually, okay, there is one, I'm reading it as a question from Discord.
Okay.
I'll phrase it as a question. Is it important to tell the language what output you want and the input you're using? I mean, I guess in line with like this here from earlier, like.
Does the language care, I guess? So there's two ways to answer that, right? So does the language care in the case of Python? No. At least not in this case, right? Will you end up caring? Probably after you after the code does what you don't expect. So let's say hypothetically I removed this, right? So let's say hypothetically I removed this. So I did kind of gloss over this a little bit, but let me show something real quick on why this would be a weird situation. So okay, so I kind of glossed over this a little bit, but so this does not do what you would expect. So in this case, B is a string, right? So I have 1 as a string. Okay. Because these aren't numbers, it's not going to perform an arithmetic. So it's not actually going to add them together. It's going to do something different, which is it is going to combine the strings. As in, you are going to get 11 as a string. 1 plus 1 does not equal 11. So, hypothetically, let's say, let me clear this real quick. So, hypothetically on our example, wow, I have hit the wrong button. My apologies. Okay, here we go. So let's say on this one that I have removed or decided to not include this int. Let's just say it doesn't exist at all, right? Okay. Probably fine, right? And let's say in 6 months, I decide I want to return a string from this for my own purposes, right? Okay. So I decide I want to call string right here. Now I get A plus B cast to a string. Okay. Reasonable, right? Except for when I call this and we execute it in, say, that add function that we have over there, we're going to end up with a very, very different result. So let me make sure that I have my math correct on this. We're going to end up with, as a string, 1, 2, 3, 4. We're just going to run all the numbers together. Having that type, while not important for the language itself to make the right decision, stops you from making mistakes. And really, in general, that's what a lot of this is for in this case. It's to sanity check yourself, because eventually a program gets large enough and you are eventually going to make an error. I mean, we're all human. It's guaranteed that all of us are going to make mistakes eventually. Hopefully that answers the question. The short is, language doesn't care in this case. Some languages will, this one doesn't. You're definitely going to care when you get a bug introduced.
I have another one from the Discord if there's any others here.
Yeah, go for it. I'm out of slides. I'm just answering questions at this point.
Are there functions that force conversion even if we're working with strings?
Are there functions that are going to force conversions natively inside of Python or just in general? Like natively in Python or one you can create? I'm going to assume that I'll answer both. Natively. That's a great question. So, to be fair, let me double check something real quick before I incorrectly inform everyone here and verify this function still exists, because Python a number of years ago actually got rid of a bunch of their function definitions. As in, not got rid of. Python 2.7 to 2, not 2.7, 2.7 to 3 had some pretty significant changes. Just want to verify this function still exists before I open my mouth on it. Yes, this function does still exist. Okay, good. So, there are a set of functions. And I wanted to make sure that I was correct on this. Okay, cool. So, there are some functions where that's actually their entire goal, is just to do a cast. Right? So, for example, we have the str function, right? str's entire goal is to convert whatever you give it into a string. Consequently, there's also a function called int. And you can give it a string. Let's say I give it a string of 2. And it will return 2 as an integer. So you can perform arithmetic on it. The reason you would want to use something like this is, let's say you got some input from a user, right? So if we go back to our input function, right here, let's say I wasn't asking for a name, right? Let's say instead I just said, please enter number. Right? Okay. In which case, and let's say I wanted to do something with this number, right? Humor me that this is a function for a second. So, if I wanted I'm just going to call this get for a second. So let's say for a minute that I wanted to get the input from the user, and I wanted to add, let's say, 3 to it, right? Okay, so I get the input from the user, and then I have something here like x equals x plus 3, right? And of course, I remember to convert this back to a string so I can print it. So in this case, if I input 1, I would get 4 back, right? So I guess the short answer to the question is, yes, there are. And they are... So let me clarify. When you call a random function, it's probably not going to change the type on you in a lot of cases. That would be a little bit confusing if you were calling a function and it decided to change it to a string just to mess with you. If it does that, it's not exactly the best design. However, in general, there are, to answer the question directly, there are native built-in functions where their entire goal is to convert the type over. And you probably will want to use them a good chunk of the time. It's a very good question, though, whoever asked it. All right. So we got 5 minutes. So I guess just plan out for this Friday's workshop slightly. So this week's workshop, similar to last week, what we're going to be doing is we're going to be applying what we've learned in here. So specifically, some of the code that we wrote last week, that was all a bunch of logic and whatnot in one place. We're going to be rewriting to be using functions. If anyone's curious what the general idea of that is and what the plan is for workshop plans. So, all right. So, does anyone have a question on anything so far? Any general areas on things we've covered? Any information from the first presentation on how it applies to here? Any general technical questions or? All right. Well, I do not have anything else.
Discord or Twitch?
I don't see any more currently, so I think we're in.
Yeah. Wow. All right. I don't have anything else to share or to really tell in this case. So, I guess we're good to call it, and I'll see you all on Friday.
Round of applause to our professor. Thank you, Random.
Thank you very much.